This is the first video that we are going to do in vector calculus, and if you are new to this expertise channel, don't forget to subscribe. In this video we are going to check how to find the tangent vector at a point, certain point P naught, where they have given the value of the parameter t is going to be 0.2. So I hope you already knew about the vector. Vector is very simple thing, that it's a kind of representation. Instead of using x, y, z coordinates separately, what they have done was for x and y and z to represent that points for x, y, z, they have used a parameter which is going to be t. So once we substituting a value 0.2, let's say here, if you are substituting the value for 0.2 for the t, you are going to get a value e to the power 0.4, which means at the x coordinate, it's going to be 0.4. Likewise, if you are directly substitute the 0.2 to this t squared minus t, you are going to get the y coordinates value. So let's say there is going to be a value. Likewise, if you are getting a value for z, if you are substituting the value 0.2 for this, you are going to get the coordinate or point of z. So likewise, this vector will have the points which the x and y z coordinates would be like this. So vector is a method of representation using a parameter, common parameter in xy or xyz coordinates. So now I hope you have understood that the vector is kind of a same thing, a similar thing, which is going to be in the xyz direction individually. If you are considering a vector, a portion individually, it's going to be x, y, and z coordinates. So from that, if you are going to find out a tangent for one axis, what we are going to do is we are going to get the derivative. Likewise, if you are going to find out the tangent for the vector, which means we are going to take the derivative for x-axis separately with respect to x. Likewise, for the y-axis, we are going to take relative to y. For the z-axis, we are going to take relative respect to z. So here we are going to do the same. To find the tangent vector, what we need to do is we need to get the derivative of the particular vector. It's going to be the similar thing. If you are doing for an x-axis, you are going to get the derivative of that particular line using the x variable. Likewise, here, since we are going to use the parameter t, we are going to get the derivative from t with respect to t. So now let's do the derivative. Please pause the video and try it in your own. I hope now you have got the answer. If you derivative of e to the power 2t with respect to t is going to be 2 into e to the power 2t. Likewise, t squared minus t, if you are going to get the derivative of that, you are going to get 2t minus 1. If you are going to get the derivative of ln t, you are going to get 1 over t. So now they have given the value for the point of that ft, which we need to find out. Which is, they have given that t is going to be 0.2. So what we can do is, now we can find out the point which is denoted by t is equals to 0.2. So how you can do that? Please pause the video and try to figure it out in your own. How to find the force or the value of a particular point when they have given that t is going to be 0.2. You can get the value or the coordinates of a particular point using, since they have given the point of that f of t is going to be when the t is equal to 0.2. So what you can do is you can directly substitute the value for this equation. If you substitute, it's kind of a line. The f of t is going to represent a line in the 3D coordinate. Let's say this is going to be the x, y, z plane, x, y, and z. This one, the f of t, is going to represent something like this. So this is going to be the f of t, and how this t will work is, let's say from the origin we are going to draw a vector. Let's say this is going to be a point of that line, the f of t. So what you can do is it's going to be like this, f of t. If you change the value of f of t, let's say f of 0.2 something, so it's going to come, it will point out to another point in that particular same line. This is going to be the f of t, this graph is going to be the f of t, and how that t will work is, when every time you are going to substitute or change the value for the t, it's going to show a different point. And always remember, these points are separately identified with these x, y and z coordinates, which means if you take these points, let's zoom out a little bit, if you take these points, there will be some x coordinate, and here will be some y coordinate, and if you take the z part, there will be some z. Since I have taken from this xy plane, it's going to be z is going to be 0, or else if you take this point, there will be some z which is going to be like this. So likewise, how to figure out this value is, every time when you are substituting a value for this one, this value will give this x coordinate of that. Likewise, every time you are substituting, let's say if you are substituting 0.2 for this one will be giving the value of y. So this is going to be the overall picture of this f of t vector. Now we have found out the point of this particular vector. Let's say this is going to be f dash, or the vector f at 0.2. Now we need to find out the tangent line of this. So how to find that? So since I have already mentioned, we need to get the derivative, and here what's the value of t? So for what the value of t we are calculating, it's going to be 0.2 again. So what you can do is, you can actually substitute the value of 0.2 and get out the directional vector at this point. So always remember, this will give you, let's say 2e to the power 0.4 comma 2 into 0.2 minus 1 and 1 by 0.2. This point or this vector will give you the direction of the tangent vector. This point or this vector will be giving you the direction of this vector. But always remember, they have asked for the tangent vector, which means they doesn't mean a direction vector only. So let's say if you give the answer, or if you stop the answer with this, what's the issue you will have? Let's say let's consider a parallel vector to this vector f dash 0.2. Let's say it's going to be like this. So these two lines will be having the same direction. If you take the parallel vector to this tangent vector, definitely it's going to have the same direction. So to differentiate that, we need to figure it out the point of this vector. We actually knew the point of that line is going to be this. So what you can do is, we need to specify the vector. Let's say that's going to be v, or let's write it as t then. So the tangent vector at 0.2 would be, first of all, we need to denote the point which is going to be 0.2. Here we have calculated that, plus lambda into a parameter, and it's going to be giving the direction 0.2. So this part of the vector, the tangent vector, will be giving the direction of that, but that's not enough. We need to specify through which point it's going. For that, we are going to use this. Though this is going to be a point vector and this is going to be a direction vector. Adding these two using a parameter, you are going to get the tangent vector. I hope this video would be clear for you. If you have any doubt, please comment below. Thank you for watching and stay tuned for the next video.